Bismillahirrahmanirrahim. I'm Aisha Nazir. The topic of today's lecture is RISC and CISC. What are these two terms? In the previous lecture, we discussed ISA, that stands for Instruction Set Architecture. Instruction set architecture is basically a set or collection of commands that we give to the processor in low-level language to perform particular tasks. In the same way, RISC, that stands for Reduced Instruction Set Computer or Computing, and CISC, that stands for Complex Instruction Set Computer, are the two types of instruction set architecture. So let's get started. Types of instruction set architecture. Computer classify into two ways. Two different processor instruction set designs are available. We can classify instruction set architecture by the ratio of complexity level of instructions. As the name suggests, complex instruction set computer architecture indicates that it has complex instructions to perform complex operations. On the other hand, RISC, that stands for Reduced Instruction Set Computer, which complexity level is reduced as compared to the CISC. So let's see. From the history perspective, at starts, computers has limited set of instructions due to limited technology. But as with the time, the technology advances, more difficult and complex tasks needs to be performed. So, to perform complex tasks, in the traditional instruction set, we added new instructions that were more complex to perform complex operations. So basically, there are few motives that drive us towards the CISC development. So let's see what are the motives. As we have discussed, with the technology, we need to perform complex operations. So to perform complex operations like floating point, arithmetic calculations, powerful and complex instructions were required. For complex data structures, require complex addressing modes too, like indexed addressing mode, based addressing mode, mixed addressing mode, and scaled addressing modes. So these data structures were required to perform the complex operations, to perform the complex tasks. So to perform complex calculations, we need a language that supports the complexity as well as that is easier to program in it. So we adopted assembly language, as it is easier to convert high-level instructions into low-level instructions. So that programmers' commands that are in high-level language can be easily transferred into the low-level language that is understandable by the processor to perform operations. Resultantly, what happened? Obviously, as we need complex architecture, the CPU becomes more slower. CPU becomes more complex. And the CPI, that stands for clock cycle per instructions, increases. So let's explore the CISC architecture deeply. Complex instruction set computer. Complex instruction set computer, that is known as CISC architecture, is an older instruction set architecture. But still, there are some significant implementations of CISC are common in use nowadays. In CISC, we need powerful instructions to perform complex operations. It means that the instructions should be such powerful so that they can easily perform the complex tasks. CISC support complex instructions, which results in few lines of code. It means that the complex instructions cause the reduction in the code size. So we can say that the CISC has shorter code as compared to the RISC. CISC main focuses is on hardware, not software. So it mainly deals with the hardware and it has main instructions about the hardware, not the software. Reduction in CISC code size increases number of cycle as it is complex. Due to the complexity of instructions, processor has to perform single instruction in multiple cycles. It has more than 8 to 10 addressing modes. That is too much for any instruction set architecture. But at the same time, it is very advantageous. How? More addressing modes makes easier to translate low-level instructions into high-level instructions. So increasing the addressing mode is a very beneficial feature of a complex instruction set computer architecture. CISC accesses memory directly. CISC use more RAM, that is memory, as compared to the registers to perform calculations. CISC execute more larger and complex assembly language instructions at a time, simultaneously. It needs better hardware and powerful processing power. At the same time, CISC use fewer lines of assembly code, each performing in multiple steps in multiple clock cycles. So it takes more time. CISC makes easier to compile higher level languages. There are multiple higher level languages like C++, Java, Ruby, Python, Rust, and many more. Complexity is mainly lies in microprocessor because CISC deals with hardware, not software. For heavy and high quality graphics for games and computation for equations, PC, laptop use CISC architecture. Although CISC is old, but still it uses in multiple different domains. Length of instruction set, that is known as instruction format, can be in variable size. It can be 0 instruction length, it can be 1 instruction format length, or it can be 2 or 3 instructions. So instruction length varies. As you can see that this is a simple example of instructions that have the variable length. So just because the variable length, it affects the performance of architecture. CISC has multiple clock. CISC has transistors for storing instructions. Increase in number of instructions, let increase the number of transistors we used. Coding in CISC processor is simple just because we are using assembly language. CISC has more data types as compared to the other instruction set architectures. So what are the main advantages of using CISC architecture? Number one, less instructions are used to program an application. Just because these instructions are very powerful and very versatile. Next advantage of CISC language is adoption of assembly language. We adopted assembly language just because it is easier to program the compiler. So just because the assembly language, it is easier to convert high level language into low level language. It supports complex data structures that we have discussed earlier. These are the advantages of CISC. What are the main disadvantages of CISC are? Number one, there are few scenarios in which few instructions that are not frequently used, but we have to include it in instruction set. That results into lengthy code. Number two, due to complexity, performance of machine slow down just because the CPU becomes more slower, complex, and the CPU get higher. CISC become more complex with new generations of computers. This is all about the CISC architecture. In the next lecture, we will see the RISC, that is reduced instruction set architecture, in detail. Thank you very much.